Let me introduce Dr. Kim Terrell, who is with the Tulane Environmental Law Center. She has done such spot-on research that is so relevant to everything related to this issue of chemical toxins. Previously, she did some wonderful work on the effects of particulate matter 2.5 on COVID. And she is, I believe, one of the most relevant researchers we have today on how toxins endanger our health and life. So, Dr. Terrell.
Well, thank you. I will try hard to live up to that introduction. And I appreciate the opportunity to share my work with everybody and to speak to y'all today. I'll try to keep this brief because I know there's a lot of other important topics to get to as well. So please feel free to follow up with me after the talk if you have any questions. So connecting health and pollution in Louisiana is really an uphill battle. And that's because we don't have much information on either. And that's not a coincidence, right? It's not an accident, I should say. So we don't have any public database for any pollution-related health problem except for cancer. And that's one reason why I've focused on cancer in my recent work. And on the other side of the equation, we also don't have a lot of air monitoring from our State Department of Environmental Quality, from the LDEQ. So if you talk to LDEQ, of course, they'll give you a very different story. They'll say we have tons of air monitors in Southeast Louisiana. We have 28 different air monitoring sites, including in Cancer Alley. And these monitors are used to determine legal compliance with 6 different pollutants. And those are listed on this screen. The problem is that not all of these sites monitor all of these pollutants. And so that's what I'm talking about when I'm talking about data gaps. We don't have a complete picture of information for these important pollutants or for the many, many other harmful pollutants that industrial facilities release. So if we look at 2 pollutants, PM 2.5 and NOx, or nitrogen oxides, these are the 2 that are very relevant to industrialized communities. And these are the 2, by the way, that Formosa's modeling predicted that there would be exceedances of the air standards of the legal limit, right? So when Formosa Plastics submitted its permit application, it did this air modeling to predict, how it would affect the air quality in St. James. And it said, oh yeah, there's going to be some violations of the legal pollution limits, but it's actually not our fault because we're not contributing that much. And so DEQ granted them the permit. But I kind of digress. So what if we are interested in those pollutants specifically? What does the picture look like in terms of monitoring sites? So if we look at just PM 2.5 monitors that are maintained by LDEQ, this is what the picture looks like. There are, and if you just look at this, so the PM 2.5 monitors are shown in red, and the other monitoring, the sites that monitor for other types of pollutants are in blue. And one thing that stands out to me is the complete lack of PM 2.5 monitors in St. James and St. John parishes. And that's why we and Healthy Gulf and others are working to try to, get some PM 2.5 monitoring done. But that shouldn't be the case, right? The burden shouldn't be on us to do this work. This is DEQ's work. And so another problem is even where you do have PM 2.5 monitors, can you guys see my mouse cursor if I move my mouse around? Pete, can you just nod or shake your head?
Yes.
Okay. So I'm going to use it as a pointer. So there's a PM 2.5 monitoring station in Geismar, Louisiana, in Ascension Parish that I'm pointing to now. And so you think, okay, well, at least the people in Ascension Parish, have data that's useful. Well, that's not necessarily the case. So if you look at this monitor, where it actually is is about 4 miles west of the center of industrial activity, which again is not by accident. And so it's not really placed well, and it's also not collecting continuous data. So if you go to the DEQ's website, you can get a lot of information about where they have air monitors. And if you click on any of these regions on this map, it'll take you to a zoomed in version, and then you click on the site itself and you can find some information about it. So here's the Geismar monitoring site. It shows you a picture of what it looks like. And if you scroll to the bottom, you'll see that it only operates once every third day. And when it does operate, it's collecting a sample that's averaged over a 24-hour period. So essentially, you're getting one number every third day to represent PM 2.5 levels for this community. So clearly that is not sufficient information, right? It's not operating all the time. It's averaging air quality across a 24-hour period. It's missing spikes in air pollution. So even, you know, as much monitors as seem to be on the ground by this picture, there's still significant gaps in the time that monitoring is happening. And again, these monitors are usually not placed in the most industrialized areas. So what about nitrogen oxides? As you can probably guess, it's a very similar picture, right? So there's a total gap in nitrogen oxide monitoring in Cancer Alley. And again, this is something that Formosa's modeling predicted was already a problem, especially in the Donaldson area around CF Industries. So, you know, I don't want to just talk about problems, I want to talk about solutions. And one thing that we can do is we can focus on data that EPA gives us that uses estimated pollution levels instead of measurements. And EPA takes those estimated pollution levels and incorporates what we know about toxicity to come up with estimates of health risk. And so when we talk about cancer risk from EJ Screen or from other EPA databases, that's what I'm talking about. I'm talking about estimated health risk as opposed to health outcomes. So health outcomes would be, you know, the number of people who have asthma, the number of people who have cancer, that kind of thing. And so if you Google EJ Screen, you can pretty easily navigate to the EJ Screen website. And I'm available to help anybody learn how to use this stuff, right? This is my job, you know, reach out to me anytime. But what I'm showing here is called the Respiratory Hazard Index, which is essentially a measure of the harmfulness of air pollution to your respiratory system. And what you'll notice pretty quickly is that the area between Baton Rouge and New Orleans and the area in Southwest Louisiana around Lake Charles stand out as having high risks of respiratory problems from air pollution relative to the rest of the country. And the same is true for cancer risks, right? So it's not just respiratory problems, it's also cancer risks from air pollution where you see, you know, much higher risks in these communities. And one limitation with EJ Screen is that it takes a long time for EPA to do this process, to make these estimates. And so what you're looking at is based on pollution levels from 2014, nearly a decade ago. And Myrtle and Barbara and other people in St. James can tell you that there have been a lot of changes since 2014 and a lot of new plants that have been built or proposed or permitted. But again, you know, this is one of the best tools we have to really hammer home the point that yes, Cancer Alley is a real place where real people are overburdened with health risks from pollution. So I did say that we do have a cancer database for Louisiana, and that kind of leads to the obvious question, of, you know, are cancer rates, are the numbers of cancer cases related to pollution levels in our state? And so if we look at cancer rates, there's, you don't see Cancer Alley standing out at you the same way that you do when we look at cancer risk. And there's a reason for that. So there are a lot of things that influence whether a person gets cancer, right? Where they've lived over the past decades, their genetics, their lifestyle, how much exposure they have to pollution. When I walk around my neighborhood, I see a lot of people sitting outside. When I walk around the garden district, around mansions, I don't see anybody on their porch, right? Sometimes people, spend more time inside versus outside and have different exposures, even if there's the same amount of air pollution in their community. So my point here is that just looking at the geographic patterns of cancer really don't tell the full story. And instead of asking, hey, are the number of cancer cases in Myrtle's community higher than the state average, we should be asking, is pollution linked to higher cancer rates across Louisiana, including, in Myrtle's community? Because like I said, there's a lot more that you have to consider in order to see that link between pollution and cancer. And so you really can't do that with the tumor registry reports themselves, even though industry tries to, DEP tries to. And fundamentally, it comes down to the point that if you want to look at a relationship between two things, you need to actually measure both of those things. And the tumor registry reports do a pretty good job of measuring cancer. They don't measure pollution. They don't include any information about pollution whatsoever. Instead, they take an area that they've decided is the industrial corridor and combine all the parish level cancer rates and then say, is that different than the state average? That's not how you evaluate this question, and it's frankly misleading. There are, as the people who live in these communities can tell you, there are parts of these parishes where people are living at the fence line of a major facility, and there are other parts of the parish where there are no facilities around. If you look at St. James, everything is concentrated in the 4th and 5th districts, but not so much in parts of the other districts. Yeah. And I see a hand, Doctor, but let me, I can pause here if you want to unmute. You're still muted.
I'm not muted. What I want to say is that there is a difference in the statistics, even so, for lung cancer alone, though. Okay.
Sure, yeah. And I try to, I generally try to, maybe we can kind of talk more about that later. I try to really encourage folks to focus on the fact that those tumor registry reports are not intended to address this question, because if we sort of point to instances that support our argument, then we kind of risk cherry picking, right? Because at the end of the day, those reports don't measure pollution exposure, and they don't account for many of the other factors that affect whether or not a person gets cancer. So and in particular, they don't account for the time gap between when you're exposed to something and when you're diagnosed with cancer. So the most recent tumor registry report includes cancer data from 2014 to 2018, and that reflects environmental exposures that happened years or decades ago, not today. So we addressed those issues and did a proper study, and spoiler alert, yes, we found that pollution, higher levels of air pollution, are linked to higher cancer rates across Louisiana. And so we used EPA data that takes basically the EJ screen data, where EPA is estimating cancer risk that is specifically attributed to air pollution. So this only looks at air pollution, and it looks at how toxic the specific pollutants are, and then provides an estimate of cancer risk. And so what we found was that it was really important to consider poverty status among these census tracts. So the boundaries that you're looking at here are census tract boundaries. And it was really important to us to look at the census tract level because that's closer to a neighborhood level as opposed to a parish level, which is so big that it includes areas that are industrialized and not industrialized. So this is what we found, and I apologize to folks who are not used to looking at scatter plots if this is overwhelming, but we found that it was really important, like I said, to incorporate poverty into this question. So both of these graphs illustrate the actual number of cancer cases on the vertical axis relative to essentially the pollution level on the horizontal axis, and specifically the cancer risk due to air pollution that EPA has estimated. And so what you'll see is that there's really no relationship between the two that is evident among affluent census tracts. So these are the top 25% of census tracts in terms of having the least poverty, if that makes sense. So they're essentially the most affluent. And then if we look specifically among the tracts that have the highest rates of poverty, we see a very clear relationship. And yes, it's not a perfect straight line. There's a lot, each point on this graph represents a census tract. And there's a lot of, what I would call noise. And that's what you get in research, especially something like epidemiology, where you're looking at something like cancer that has so many different risk factors and is such a complex, really, set of diseases. So going back to the cancer rates, it's no surprise to me that if you look at Cancer Alley, you have some census tracts, with higher or lower cancer rates compared to the state average. And that's because if you look at the same area, if you look at poverty rates, poverty also varies tremendously within the industrial corridor, within Cancer Alley. So the biggest kind of dark blob that you see in this zoomed in inset is St. James, and this is the 4th district to the north and the 5th district to the south. And so, again, this goes back to the point that where you have high rates of poverty, you see more clearly the link between pollution and cancer. And there's a couple different potential explanations for that I'm happy to talk to anybody about afterwards. And so we know that it's not just simply a function of poverty, because if we go back to these scatter plots, if you look at communities that have high rates of poverty but low amounts of air pollution, some have higher rates of cancer, some have lower rates of cancer. But as the pollution risk increases, you don't see low cancer rates anymore. Overall, you see this trend of increasing cancer rates. So it's very clear, based on our study, which is currently in peer review and should be published in the next couple months, that toxic air pollution is linked to higher cancer cases among impoverished communities in Louisiana. And getting back, I'll wrap up soon, I promise, but getting back to the issue of air monitoring, many of DEQ's monitors are used to determine whether cancer-causing pollutants are above legal standards. The answer is a little complicated, but the short answer is few to none. So DEQ, the DEQ does not use these monitors to look at cancer-causing pollutants. It uses the monitors to look at common pollutants that are called criteria pollutants that are harmful, things like PM 2.5, but are not cancer-causing. And so they do operate some monitors that measure VOCs, volatile organic compounds, and some VOCs, not all, but some VOCs are cancer-causing. The issue is that they don't measure all cancer-causing pollutants. They don't provide continuous data. All of these VOC sites are sites that measure once every couple of days or when triggered by very, very high levels of pollutants. And DEQ doesn't even do anything anything with the data. It doesn't analyze and calculate averages the way that it does for those criteria pollutants. And then even if it did, the air standards, the legal limits for toxic pollutants are outdated and they are not protective of human health. The last time they were updated was December 2007. We're almost on the 15-year anniversary of when these standards were updated. And in many cases, for many pollutants, the standards are hundreds of times higher than what EPA considers to be safe. And so we had looked at that in the context of Formosa Plastics, and I'm not going to go through this table, but we had, you know, everything that Formosa is permitted to emit, we looked at and we said, how does the Louisiana standard compare to the EPA reference concentration? The reference concentration is what EPA considers to be a safe level. In many cases, there is no reference concentration. The EPA hasn't gotten around to evaluating it. But we do have some examples like cumene, where the Louisiana standard is almost 6,000, and the EPA says, okay, we consider 400 to be a safe level. Similarly, hydrogen sulfide, which is not cancer causing, but it is harmful to human health. The Louisiana standard is 165 times higher than what EPA considers to be safe. Dimethyl sulfate, which is classified as a probable carcinogen, meaning that the science suggests that it probably is cancer causing, doesn't even have a Louisiana standard, meaning that there is no legal limit for how much of this pollutant can be in the air. And so again, I'm happy to talk to anybody more about this, but to wrap up, I want to make 4 quick points. We need advocates to support better air monitoring that measures the right pollutants at the right places at the right times, you know, ideally continuously. We need advocates for better air standards that are based on the best available science, that are updated regularly and rely on reasonable risk thresholds, because it probably won't surprise you to know that DEQ has a very lax threshold of what it considers to be acceptable risk. We also need better health data. We need to know how many people have asthma, how many people have COPD across Louisiana. And we need this at the fine scale, not for parishes. We need this for neighborhoods and census tracts. And we need DEQ and decision makers and others to make better use of the existing data that we have, to really acknowledge that EPA's EJ screen clearly indicates that Cancer Alley is overburdened with health risks from pollution. And when these decision makers do use health data, to account for the fact that there are many different things, including poverty, that can influence a health outcome and may explain why you don't see a clear geographic pattern of a health outcome in Cancer Alley. So with that, I want to wrap up. I don't know if we have time for questions, Peter. I'm happy to take them now or later, whatever works best for the group. But thank you all for listening.
Yeah. Let's do some questions. That was awesome. And Kim, let me start. Is it too much to say that both governmental and corporate petrochemical decision makers believe that low-income communities are powerless, and therefore they represent the path of least resistance for siting these facilities?
So it's definitely consistent with what we see. I think other folks in this group could probably, speak passionately to that. But I think St. James is a great example. And, Ann's organization, the Bucket Brigade, put out a really compelling report that shows that, disproportionately the Black neighborhoods in St. James don't receive the same level of protection from industrial development that the white communities receive. So that's definitely, definitely consistent with many people's firsthand experience.
It was interesting to me in Memphis, they wanted to run a pipeline right through an African-American community. It led to huge community organizing and real good backlash, which eventually stopped it. And during this process, a company executive was quoted by saying, we assumed that was the path of least resistance. So I think it's pretty transparent how these decisions get put together, both by DEQ and by the industry themselves. Questions or comments? Nothing?
I see Robert, or Robert, I'm sorry.
Yeah.
And I know Dr. Butt has another question, but maybe we'll start with Robert.
Yes,
Yep.
Thank you, Dr. Terrell. I'm curious whether these slides are available. I would like to use them and show them to other people.
Yeah, absolutely. I will send them. Pete, how about if I send them to you and you can distribute them? Does that work?
Absolutely. Thank you.
Okay.
And Renata, and then Dr. Glenn.
Yeah, I wonder if you have any idea or any suspicion what might explain that people in poorer communities experience more cancer.
Yeah, that's a great question, Renata, and it's good to see you again. So two things immediately jump out to me. One, and both are sort of based on personal experience. I live in a neighborhood in New Orleans where I think one person on my block has been here for more than a decade, right? It's a relatively affluent, relatively white neighborhood where a lot of people move around. And if you think about it, if people are moving and coming in and out of a neighborhood, you're not going to see that link between pollution and cancer, because maybe last year they lived in New York and my other neighbors just moved in from California. So geographic mobility could be an issue. And you contrast that with talking to people like Myrtle and Barbara who have lived, in the same neighborhood their whole lives. So that could be at play. Also, people who live in more affluent areas may have homes that are more airtight. And again, when I bought my house, it had gaps, it had, all kinds of problems. My husband's been fixing it up and now it's pretty airtight, right? And we're fortunate to have the resources to be able to do that. And so that kind of gets, again, back to, people in areas with higher poverty may live in homes that do not protect them from outdoor air pollution the same way that more affluent communities do. And then, of course, there's differences in access to preventative medical care, and lots of other explanations that, we can kind of speculate on, but it's really hard to answer those questions definitively.
Okay, Reverend Jim, then, Glenn, I'm sorry, you're next. And then we'll have Reverend Jim and then Thor.
Can we get the EPA to act on this? I was wondering if you found any correlation with mask wearing and improvement in the situation since COVID started?
So first, with your first question, I think, so my first step is to get this peer-reviewed and published, because as you probably know, it's one thing to put out a report, it's another thing to put out a peer-reviewed study. So once that is out, I do think the time is good to try to engage EPA's national office, because as everyone knows, we're in a new era where all of a sudden engaging with EPA is, maybe more productive than it might have been about a year ago. So I do think it's a good perspective and a good point that this information needs to get in front of the right decision makers at EPA, and I will do my best to make that happen. I don't know, I'm not familiar with mask wearing. Can you kind of give me like a one-sentence explanation of what that is so I can answer that question? Oh, you're muted.
If you use an N95 mask, it's supposed to remove the P2.5.
Oh, I'm sorry, you said mask wearing. I thought you said mass squaring.
No, wearing, sorry.
Like, about some statistical technique that I'm not familiar with. So yeah, definitely, those masks are important in obviously protecting people from PM 2.5. And it's important to know that PM 2.5 can basically act as a delivery system for toxic air pollutants. So those particles can basically pick up chemicals that are carcinogenic, that are cancer causing, and PM 2.5 itself can cause lung cancer. So yes, definitely those masks are important and can help. Having said that, there are also, cancer causing air pollutants that will get through those masks just due to the small size. So yes, it helps, but it's not a complete solution.
And Reverend Jim?
When you say DEQ, is that federal or state? And this is a two-parter. And does the LDEQ have a role to play in setting up the type of monitoring that we wish had happened 20 years ago and we're pushing for now?
Yes, they do. They are a state agency and they are overseen by the EPA, which is a federal agency. And in Louisiana, the DEQ is primarily responsible for air monitoring. Sometimes EPA will step in and supplement, and that's something that's happening in St. John. But unfortunately, our region, so EPA is divided into regions. There's, I think, 7 or 8 regions across the country. Our region is notoriously biased towards industry, which might not surprise many people, right? So our region includes Louisiana, Texas, Arkansas, Oklahoma, and New Mexico. And so, yes, this should really be the job of DEQ. And I think now probably our path of least resistance is to try to engage EPA to put pressure on DEQ. And engaging EPA can also mean engaging the national office of EPA to put pressure on the regional office to put pressure on DEQ. And then at the same time, working to get information ourselves, right? So like I said, Scott's been out there, putting up monitors. By the way, I'm publicly thanking Scott for saving our monitor from Hurricane Ida because he was out there taking it down when I was already out of town and couldn't do it myself. So I do think, it's a multi-pronged strategy and we need to keep the pressure on the people who are supposed to be doing this work, but we also need to find opportunities to get the work done ourselves.
Okay, and Thor, I think I'm going to give you the last question and we'll move on to Ms. Gale and Ms. Barbara.
Yes, the West Coast, it's actually kind of a two-pronged information / question. The fires up and down the West Coast are contributing an air quality issue here and apparently all the way out to New York. And so you're going to pick up an increase in particulate matter. And apparently the smoke is known to have a high resonance in the 2.5 micron range because it's actually burned soil. Every time a house burns up, you get a lot of all kinds of toxic things. So I noticed in the smoke maps that Denver got a particularly heavy amount of this, and for some weird reason, you form an eddy in the Texas region. The second is wind velocities worldwide are accelerating about 1% to 2% per year. And so you're going to get a gradual dilution factor. We see this as a pink dust sometimes on the vehicles around here that comes from the desert in China. And the dust didn't used to be able to cross the ocean. Now it does quite regularly. That's a fact of climate change, but this will mean that you get a progressive dilution rate in the Louisiana area. So if your data is really sensitive, you should be able to pick up both the fires and this dilution factor.
Yeah, I'm curious to learn more about that. Both of those points are not areas that I'm super familiar with, but I will say that we have our own sort of version of wildfires down here, and that's sugarcane burning. And in the fall, we see huge, increases in PM 2.5 pollution. And one challenge again is that a lot of the DEQ monitors, they're taking a 24-hour average. So those spikes really get diluted out in that averaging period. And I think have a healthy dose of skepticism as to whether DEQ's monitors will be sensitive enough to pick that up. But it'll be interesting to see for sure. So thanks for sharing that.
Just mention one other detail. The refineries here in the Northwest, particularly clustered to the north of us about an hour, they release most of their pollutants during the storms. Episodes of high wind. And they actually have some sort of sensor on their smokestacks to regulate, that's a signal that they can increase their load by up to a factor of 20. Because we noticed that the particular amount in the downstream city, it smelled unusually strong during a winter storm. And we found out they were putting out about 100 times more pollutants during that storm.
That's really interesting to know. And that one area that I think we don't have enough expertise in is control technologies and technologies that can be used to protect people from industrial pollution. And one side of me says, wow, that technology should be adopted here. And then the skeptical side of me, or the maybe jaded side of me said, well, yeah, these plants will just use that as an excuse to crank up their annual, emissions. But I appreciate you sharing that because I'm not familiar with that technology. So thank you.
I just raised this because my part of my family is in the photonics industry, laser sensors and lab calibration techniques. And I really have a question about the type of sensor that you're installing. Because if it does data logging at maybe like a minute or 10-minute intervals, or you get some sort of profile, you should be able to pick out these events, both of your local industry dumping more in storms and smoke events from the Northwest. Because all you have to do is connect it to an anemometer to say this is what your average wind speed was through the area. In a lot of data sets, that's necessary in the scientific community because you use this as cross-validation. Because I used to work in the healthcare industry briefly. We use the CDC flu charts to corroborate whether or not facilities receiving patients. As the flu is more active, that means you get a higher patient load, and your facility should be recording that as patient's treatment. And that was very persuasive to a lot of people to say that this is the correct way of setting your policy.
Thank you, Thor. Kim, any comments on that?
Just real briefly that I do know that one challenge we have is the shorter the time period that you look at for air quality measurements, the more noise you get in the data. Because we've operated low cost monitors and EPA grade monitors side by side. And the really only way to get them to kind of correlate with each other is to look at a 1 hour average as opposed to a 5-minute or 10-minute. So I think, that is a continual challenge to sort of fine scale, temporal fine scale monitoring. But as technologies improve and as we get more options, I definitely hear your point that it's important to kind of correlate that information with wind data. So again, thanks for sharing your perspective, Thor.
Kim, that's fantastic data. And just so everybody knows, Together Louisiana is going to be hearing from Kim on October 4th. Aaron, we could possibly recruit a bunch of people for Together Louisiana right here and now. Could you put a link to how you get signed up with Together Louisiana in the chat? And I would recommend, if Inclusive is not part of it, that they join, and other organizations here also. So Kim, thank you. And I'm looking forward to going through this again on October 4th. And please do, if your organization's not part of Together Louisiana, please consider joining, because air monitors is priority number one in the coming year for Together Louisiana.